It is Advent of Code, day 13. And here we go. Okay, this is a grid problem. Mirrors, okay. Oh, it's a bunch of different grids, and they each have some reflection access. Okay. It can either be between two columns, or can it be on a column? Or on a row or column? Perfect reflection across either... Oh, it's always between... Yes, okay, it's always between. So... There we have the grids. I think we just are going to try every possibility. The number of columns to the left of each vertical line. Okay, so we just got to figure out where the reflection axis is in each one. How do we want to check this? Okay, let's do... So reflected across... so we'll do like in between... I'll do this to denote like between I and I plus 1. And what that's going to mean... If gxy is equal, or if it's not equal to, okay, so we're reflecting across the x first, and what this is going to mean is, so the new x is going to be I, does I minus x, then when it's equal to I plus 1 plus I minus x. Do I have that right? When x is exactly equal to I, then we should reflect I plus 1. Yes, when x is equal to I minus 1, we should, let's see, then this should be 1, we reflect I plus 2. Okay, that checks out. And then this will be unchanged. And if they don't match, then this can't be a reflection. If we get to the end, we're done. If it reflects onto somewhere, what's stopping us from always checking at the very end? I guess we just don't consider that one. We need to reflect. It just doesn't need to be between two rows and between two columns, so I think this is fine. My naming here might be off in the check C or check R. I'll need to think about which one is rows and which one is columns later. I've not thought about that carefully yet. This should be the same logic. It's going to be j plus 1, j minus x, but then x is unchanged, and this is the y, j minus y. And then this is unchanged, I believe. And now what we'll do is, since it's I and I plus 1, so I can be 0 is fine. N minus 1 is not fine. It must be n minus 2 is the upper bound. If check R, G, N, M, I. So now we got to think about whether this is rows or columns. So if we're reflecting the x coordinate, x is our row number. So if the x coordinate changes, then we're reflecting in between two rows. Number of rows above each horizontal line of reflection. Okay, so then oops. Oh no, typing. Okay, rows above. This should just be I. If it's I plus 1. Because if it's 0, then that's 0 to yes, okay. I guess I shouldn't need this. And then this should just be j plus 1. And then I think that's just it. Oh no. Where? Oopsies. Oh my god, I can't click. Okay, rank 17. Part 2. Each mirror is exactly one smudge. Locate and fix the smudge that causes a different reflection line. Okay. I think we just count up the differences, and then if there's exactly 1, yeah, then it's good. So this is the mismatch. If it mismatches, then we do this, and then oh my god, typing on a laptop keyboard is not great for me. Ooh, it did not work. It's unfortunate. It must be different. I guess maybe I need the old behavior? I'm a little confused why this doesn't work. Are we not finding anything? Oh, there should be exactly 2. This is like an even odd parity thing. I'm going to submit this, and then if this doesn't work, I'm going to add the logic to make sure the line is different. Because this might just work. Okay, this worked. Rank 5. Whew, that is a good day. That is a very good day for me. Oh, man. Okay. Yeah, I'm happy with that. 17 and 5. Yeah, I think part 2 was... Like, this should fill up pretty fast, I feel. I'm surprised no one else solved it. Huh. Yeah, I think part 2 is not a big difference here. I guess if what you did was reflected and then checked, like, equality, then maybe, like, adding up the mismatches is harder. But, this is, like, a very small change to my code. Yeah, I guess there's no way that you'd have to, like... Oh, maybe or people parsed this and they saw the bit about, like, it needs to be a new reflection line, and they explicitly added that logic. I think the fact that the count has to be equal to 2, like, if you do less than or equal to 2, this will clearly be wrong, because you will accidentally use some of the earlier lines. So you get, like, something... Well, it's not really in between because it's not additive, but doing equal to 2 guarantees you can't use the old line because the old line would just have count equals 0 because it would match perfectly. Cool. Yeah, and then if you didn't pick this up, the reason it has to be 2 and not 1 is because I go through the entire grid and I reflect across. So rather than when I have like a possible reflection line, did part 1 cap? I guess I'm curious. Oh, part 1 I hadn't capped yet. Okay. Okay, and part 2 is filling up fairly fast now. Oh wow, Antonio had a number 2 finish on part 1. That's crazy. Man, how far off was I? Oh, quite a bit, right? 550. Wow. Sometime I really want to go back through my recordings and sort of think about where I could pick up time. Because I felt like this was a very good day. There were no bugs or anything. I mean, I guess having good library code, like if I had implemented... There's a lot of things I feel for advent of code you could implement ahead of time. I guess even... it shouldn't do much. If I had like a utility function called like grids, which does this splitting on double new lines, and then... Yeah, I don't know. I'm a little hesitant to add too much like library code that just does stuff for me. I did write this AOC tools thing, and I did write like a lot of cool stuff here, but I've effectively never used any of it except for nums, which is actually a pretty handy function that just finds like all the numbers in a line, like extracts the digits. Yeah, I thought that these would be very useful for like early days. Like often you just want like a rolling sum or something, and having that implemented seems nice. But I think I don't know if I could have used any of these this year, or if I just like could have and I forgot about them, because it is true I've kind of forgotten about a lot of these. Yeah, well, I guess I can explain a little more about today while I wait for leaderboard to fill up to see where I end up on leaderboard. I guess it will take a minute or two. But yeah, I guess I'll go ahead and explain the problem. Cool. So we're given a bunch of these little grids, and we're sort of told that each of these grids has some symmetry. And that symmetry is either like a vertical or a horizontal symmetry. And the line of symmetry is always in between two other lines. So in this example, it's between these two rows. And you can see that this is like symmetrical. Oh, wait, is it not? Wait, what? Oh, no, I was wrong. This is a vertical line of symmetry. Wow, I saw this and I assumed too quickly. Yeah, I think this is a vertical line of symmetry in between these two columns. And this one is horizontal in between these two rows. Well, anyways, we're told that there's some vertical and horizontal lines of symmetry, and the question is basically just find all the lines of symmetry. You have all the grids, and it wants you to aggregate them in a certain way, where you like take the index of the symmetry line and add, if it's horizontal, or if it's vertical, then you add that. If it's horizontal, then you add 100 times that. It's just like some aggregation method. And yeah, I think this is mostly a just do it. I think there's not really much clever you can do here. I guess there probably is some clever algorithm you could do if you wanted to be really fancy, but really all you have to do is try every possible vertical and horizontal line and just like see if it is symmetrical across that. So I wrote these two functions which check symmetry. One big thing here to worry about is off by one indexing. It's like very easy to mess up indexing on these kinds of things, especially when you're in between two rows and columns. So I definitely slowed down a little bit to think carefully about this, which was good. It was correct, so that's always good. And then the other, so that's I wrote these two functions, and then I just like check every possible one of them. I think I wasted time writing this if not F thing. Like if we found a symmetry line, I think we just should not find another. So I can just test that. If I get rid of this. Yeah, that's the same. I had a feeling this was unnecessary because if you can't have vertical and horizontal symmetry, because if you did, it would be ambiguous which one to use. And there's nothing here about like tie breaking between them. So it has to be the case that this input is only vertical or horizontal for each one. I will leave that in the code though, just for posterity. But yeah, so I just check every possible one of them, and then if I find it, I add it in the way that we're told to. The other thing to catch is to make sure you don't mess up the 100 times and then like which one is vertical, which one is horizontal. I spent some time thinking about this too, to be careful. And the way I sort of thought about this is like my x coordinate is the first index. The first index is the row. If I am changing the x coordinate to check symmetry, then that means I'm comparing one up here to like one down here, which means I'm doing a horizontal line of symmetry, which means like vertical symmetry. And then I looked and I'm like horizontal line of symmetry, horizontal line of reflection is 100, and that's how we got that. Yeah, when I wrote this check R and check C, R and C were completely random. I had no idea if this was rows and this was columns. I figured I would just like iron it out later. Which is what I did, and that worked out. But yeah, that's part one. And then part two just says, okay, well now the reflections are not perfect. Now there is exactly one difference in the reflections. So it's a thing that does not line up between the two. And with my approach, this is like very simple. Rather than just like return false whenever you see a mismatch, you just add to a counter, and then you have the correct symmetry if your counter is exactly 2. And the reason why it's 2, like I was saying earlier, is because I'm checking the whole grid. So if I have one mismatch, then I'm kind of going to see that mismatch twice. Once when I check it, here, let me find a good example. Here is the wait, no. It compares this against this. Wait, where's the smudge? Top left. Oh yeah. It was this one. Yeah, and when I see the first pattern is this one. Yep. So when I check this, I realize this doesn't match. Was when I am looking at the correct reflection line, which is in between these two rows. When I see this, I see it doesn't match this. I added the counter, but then also later on, I'm going to see this, and I'm going to reflect it back across this and get this thing. So I'm going to see that twice, which is why I need to check that the counter is exactly equal to 2. But if I just do that, then everything else stays the same, and it's like a very fast part 2 for me. So yeah, that is, I think, all there is for today. Hopefully now the leaderboard is capped and I can see where I have moved up. Yep, okay, cool. Let's take a look. And, oh, I'm up to number 10. Wow, that is a big improvement. That's cool. Nice. It'd be very nice if I managed to end top 10 this year, especially after these unimpressive days where I got very few points. Cool, that's exciting. Well, yeah, that is all I have for day, what was today? Day 13, and I will see you all tomorrow.